So this is question 4A from 9.2 review question. So this is the question. So we have to balance it if in a basic condition. So once again, we have this table again, and this time we'll be focusing on this one. So remember that a monoatomic oxidation number is the same as its charge. The ion is the same as its charge. So now this is the equation we have earlier, and as you can see, it has charges and everything. So our first step is to put the oxidation numbers that we know from the table itself. As we can see, oxygens will all be -2, hydrogens will all be +1, and as we can see here, Cl, because it has a charge of -1, its oxidation number will also be -1. But now, as you can see, we have unknown oxidation numbers like for these chlorines and these leads, so we need to find those out. So it's as simple as we've done before. So because we know that this entire thing has a charge of -2, we're going to put -2 on the side instead of 0 of a neutral charge because this is a -2 charge. And then we're going to put X as lead. We have 4 oxygens, so 4 times -2. And we also have 4 hydrogens, so 4 times 1. And then we can solve that by multiplying, and we can rearrange it. So this will get us X equals 2, which means lead is 2. We can do this for chlorine. Once again, because this has a charge of -1, so we put -1 on the side, X for chlorine, and -2 because we know oxygen's oxidation number, and we will get X equals 1, so this means chlorine's oxidation number is 1. We can do this for this lead as well. Once again, this doesn't have a negative charge, so it's neutral, so we put 0, X for lead, -2 for O2, multiplied by 2, and we get X equals 4, so this lead is 4. So now we have all the oxidation numbers, we write them down, +2, -1, everything. Oh, sorry, this is +1. I don't know why I put -1. So now we know we want to write if it's oxidation or reduction. So over here, we are oxidizing. So this lead to this lead, we have a +2 on this side, while over here we have a +4. So we are increasing the number, so that will be oxidation. While this chlorine to this chlorine, we start off with a +1 and we end with a -1. So we are reducing that number, so that makes it reduction. So now we're going to separate the oxidation and reduction into two separate equations. So over here, we have our oxidation equation, and over here we have our reduction equation. So these are going to be our half reactions to make everything easier. So next thing we want to do is write down them one by one, and we're going to start balancing. So first of all, we want to start balancing the elements itself other than oxygen and hydrogen, but those are already balanced, so we can move on to the next step, which is balancing the oxygens. So to do that, we're going to be adding water, and as you can see here, we add we add two waters, and we can do a simple T table to see how many oxygens and hydrogens we have before and how many we have after. And as you can see, now we have 4 oxygens and 4 hydrogens on both sides. So that's balanced, so we can move on to our we can move on to our reduction half reaction. So over here, we can add a hydrogen, so we can have equal amounts of oxygens. But as you can see, now we have 1 oxygen on each side, so those are balanced. But now we have 2 hydrogens on the product side. So that's not what we want, so we have to move on to the next step, and that is balancing the hydrogens. So as you can see here, we add a +2H plus on this left side. So as we look at our T table again, now we have 2 hydrogens on each side, making the hydrogens also balanced. Our next step is, because this is in a basic condition and we have just a lone H plus here, we can't have that. So now we have to add minus OH minus to whatever H pluses we have. And we also need to balance that on both sides. So as we can see here, we added two OH minus to this side, making it 2 waters. And over here, we also have 2 OH minus because we added 2 OH minus on the reactant side. So we have to add it to the product side as well, just to balance it out. Okay, now that's done. Now we have both our reduction and oxidation half reactions back. So now we need to balance the charge. As we can see here on the reactant side, we have a 2 minus here. So we're going to add a 2 minus on the other side. And as you can see over here, we also have 3 minus on this product side. So we're going to have 2 minus on this product, on the reactant side, since we already have a 1 minus here. Our next step is we just need to add these two together. So we get this really long equation. So we need to simplify this. So we cross out whatever we have multiples of on both sides. So as you can see here, we can just cross out both waters, but this has one water left, and we can cancel out the two electrons on both sides. So now we get this. This is our equation. As you can see, we've simplified it. So now we can check if our equation is correct by doing more tables. So over here, we can check the elements on the left, the reactant side, and the right, the product side. And as we can see, we have the same amount of elements on each side. Next, we can also check the charges, which are highlighted in yellow. And there's -3 on the left side and -3 on the right side, which means it is also balanced. So finally, this is our balanced equation. Okay, thank you.